This video is on solving radical equations. We have the steps to solve right here. If we're going to be solving anything, we have to remember that we're going to be using the order of operations, but we're going to go in the inverse operation, so backwards, which means for some people will remember SADMEP. SADMEP, we want to add and subtract away first, multiply, divide, then get rid of our exponent, then worry about the parentheses. The first step that we're going to do is we're going to isolate the radical. We can isolate the radical, either the radical itself or a rational exponent, depending on the type of problem it is. So to isolate the radical, you should determine what the radical is and know what part to isolate. So I'm going to highlight the part that we need to isolate. The second step is we're going to raise the entire equation to the power of the radical, which means we're going to raise it to the index because we want to get rid of that radical. So if we want to get rid of a square root, we square it. If we want to get rid of an eighth root, we raise it to the eighth power because that's the exact same as the index. Or we'll do the reciprocal of the fraction exponent. That's going to be when we talk about rational exponents. Step 3 is once we get the radical gone, we're going to just solve for the variable. We're going to go back to SADMEP and solve for the variable. The last step, and this is crucial, you must plug your answer into the original problem to make sure they work. Because when we're dealing with solving radical equations, you could end up with extraneous solutions. Extraneous, E-X-T-R-A-N-E-O-U-S, extraneous solutions. We always have to check for these extraneous solutions. Extraneous solutions are, another word for that would be called a false solution. A lot of times what happens is you might get two answers and one of them works, one of them does not work. It doesn't mean you did anything wrong, it just means that in that context of that problem, that answer doesn't work. So we always have to check. You must always check. Check for extraneous solutions. So we're going to do 4 examples on solving radical equations. So again, the first step is isolate the radical. So I'm going to highlight the radical and the radicand that we have to isolate. So on this first example, I start with the radical and I highlight everything in the radicand. I ignore the coefficient. I am looking at just the square root of x plus 3. I want to isolate that, which means that I need to get the coefficient away from it and also anything added or subtracted to it. So I'm going to get the adding and subtracting. There is nothing added to the left of our highlighted aspect or added or subtracted to the right of our highlight, so that we have the equal sign. That means that step 1, isolating the radical, has already been done. So now I want to come here and raise the entire equation to the power of the radical. So since this is a radical, I'm going to rewrite this problem as the square root of x plus 3 equals 5. I'm just going to rewrite the problem because I don't really want to mess up my original, because I do have to check my answer in my original. So now, in order to raise it to the power of the radical, I raise both sides of the equation. The index is 2, so I have to raise it to the second power. Both sides. The reason we do this is because the square root and square are inverses of each other. They will cancel each other out. So we'll be left with x plus 3 equals. We are squaring 5, so that just becomes 25. Now that we've gotten rid of the radical, we solve for the variable. So we want to solve for x. To solve for x, we're going to subtract 3, and we end up getting x equals 22. Now, I am not going to circle this yet because I need to check it first. Checking it, because this is step 4, I'm going to put a little check mark down here. I'm going to put this back into the original problem, which was the square root of 22, because that's our x, plus 3. is that equal to 5? 22 plus 3 is 25. Square root of 25 is 5. So this works. That means that we can say that this is our correct answer. And I'm going to highlight my answer, saying that this is correct. Going to highlight it in orange. Say this is our final answer. Example 2. This is a radical, so I want to highlight my radical and my radicand so I can isolate it. So again, we focus on our radicand and not our coefficient. The radicand is x. That plus 3 is on the outside. So I only want to highlight the square root of x. Notice I did not highlight the 3 as a coefficient, the 3 added to it, or the 15. So I want to take this problem, 3 square root of x plus 3 equals 15. And I know I have to get the square root of x by itself because that was what's highlighted. So solving, to isolate it, we have to add and subtract first. That means I need to subtract this 3 because this is what's added to it. So we have to do the inverse of addition, which is subtraction. So we're left with 3 square root of x is equal to just 12. Then we want to multiply and divide it. It is multiplied, so we need to do the inverse of multiplication, which is division. We want to divide by 3 on both sides. So we'll have the square root of x is equal to 4. We have isolated the radical because that highlighted part is now alone. Now we want to raise it to the power of our radical. So raise both sides of the equation. It was a square root, so we raise it to the second power. We'll have x equals, because x will be alone, I can go ahead and put my x equals 4 squared is 16. Now again, I'm not going to circle it yet or highlight it because I need to check it. So I'll put my check mark. We have 3 square root of 16, then plus 3, and the question is, does that equal 15? And you can use your calculator. So I have 3 square root 16, get out of the radical, plus 3. That does equal 15. That means it does work. I can put a check mark, say yes, that works. That means that x equals 16 is a correct answer. I can highlight that, say yes, this is correct. Going on to example 3. Again, I want to isolate the radical. Since this is a radical, I need to highlight the radical itself and the radicand, which is y minus 2. So I highlight the square root of y minus 2. Now I want to isolate that. Square root of y minus 2, and then minus 1 equals 5. In order to isolate that, we need to add the 1 over to the other side, because subtraction, we have to inverse of subtraction. Square root of y minus 2 is equal to 6. Now that y minus 2 is in the radicand, there's nothing multiplied to the radical, so that means it's isolated. So now we can raise both sides to the power of the radical. It was a square root, so we raise it to the squared power. We end up getting y minus 2 equals 6 squared is 36. And again, we just want to solve for the variable. So now we would add the 2 over. So we'll end up getting y equals a positive 38. So again, I'm not going to highlight it yet. I need to check it. We have the square root of 38 minus 2 inside of our radicand. Minus 1 is supposed to equal to 5. So we're going to put question mark 5. So 38 minus 2 is 36. The square root of 36 is 6. 6 minus 1 is 5, so it does work. Again, you can check that in your calculator. So far we don't have any extraneous solutions. That's perfectly fine. This last example on solving the radical equations. Again, I need to isolate my radical, so I'm going to highlight the radical and the radicand. So the square root and the 11x plus 3 is my radicand, so I highlight that. Now we need to isolate that. I'm going to rewrite the problem. Square root of 11x plus 3, and then minus 2x equals 0. We need to isolate this by adding the 2x to both sides. So we have the square root of 11x plus 3 is equal to just positive 2x. The radical has been isolated. That means we can get rid of the radical by raising both sides to the power of the radical, so square it. So we're left with 11x plus 3 equals 2x squared is really 2x times 2x. So this is actually 4x squared. So now we have a quadratic term, a linear term, and a constant term. Well, since we have a quadratic should be equal to 0. So what we want to do is take this and solve a quadratic. So I want to get my quadratic equal to 0. Well, my quadratic term is positive, so I want to keep that positive 4x squared. But I needed to move my linear and constant term to the other side, so I know I'm going to have a negative 11x and a negative 3, and that will equal to 0. Now, to solve a quadratic, we could use quadratic formula, but it's potential that it will factor. So I actually want to see if it will factor. And if we remember, we can use the discriminant to see if it will factor. So discriminant is b squared minus 4ac. So parentheses, b is negative 11, parentheses squared, minus 4a, which is parentheses 4, parentheses, c, so parentheses, negative 3, close parentheses. This is equal to 169, which is a perfect square. It's a positive perfect square. This will factor. So let's try and factor this problem. If we try and factor it, we would start with 1 and 4x or 2 and 2. So I'll start with 2x and 2x. And then we'll have the factor of the back term are 1 and 3. 1 and 3. So we have 2 and 6. 2 and 6 will not give us an 11. So that means that even if I change my 1 and 3, that will not change the problem. So that means that my front numbers actually need to be changed. Instead of 2 and 2, I should try 1 and 4. So I'm going to try my 1 and 4 instead. So this is why I chose pencil on this one. I'm going to have a 1x and a 4x. So let's try this. So now we have a 4 and a 3, which 4 and 3 will not give me an 11. But because I can still rearrange things, because these are not the same number, if I change those around and make it a 4x in the first one and a 1x in the second one, let's try that. So 4x in the first one and then 1x in the second. So now we have 1x and 12x. Yes, 1 and 12 will give us an 11. Now we need a negative 11, so we need a negative 12. The 4 and the 3 is what give us the negative, or sorry, give us the 12. So the 4 is positive, the 3 has to be negative. That means we have a 4x plus 1 and an x minus 3. Now we want to solve. These are equal to 0, so we have 4x plus 1 equals to 0. That means that x is equal to, we subtract the 1 divided by 4, so negative 1 over 4. And then if we add 3 divided by 1, so x is equal to a positive 3. But now we have to check. So now we have two answers, so we definitely have to check for extraneous. So to check, we have the square root of 11 parentheses negative 1 over 4 close parentheses plus 3. And then we will do minus 2 parentheses negative 1 over 4 is supposed to equal to 0. So if we check that, we have the square root of 11 parentheses negative 1 over 4 close parentheses plus 3 out of the radical minus 2 parentheses negative 1 divided by 4 close parentheses, and that is equal to a positive 1. It's supposed to equal to 0. So that negative 1 over 4 is extraneous. That one does not work. Okay, so then we also have to check the 3. So I'm going to do the same thing. So check square root of 11 parentheses 3 close parentheses plus 3. Then minus 2 parentheses 3 close parentheses is supposed to equal to 0. So this time when I type it in, I'm going to do the same thing. So square root of 11 parentheses 3 close parentheses plus 3, get out of the radical, minus 2 parentheses 3 close parentheses, and that one is equal to 0. So yes, this one does work. This one works. That means that the x equals 3 works, so I can highlight the x equals 3, but what we need to do with the x equals negative 1/4, we need to write that this is extraneous. So I'm going to put extraneous, because that is the solution we got. We didn't do anything wrong. It's just, it was extraneous. So definitely write on here that this is extraneous, but you can't highlight it. So always check for extraneous solutions, because you never know. Even if you only had one answer, it might have been extraneous.